All right, so let's hit these. The first one is what we call a full section, and we're going to start on figure 1625. A full section, a section which passes completely through the part. So a full section. Section which passes completely through the part. This is a real useful section when we have shelled objects or linear objects with interior features. In essence, also, it's the one where we mentioned yesterday, you do not have to show a cutting plane line if the cut's obvious. This is about the only one where it's really obvious, okay, is the full section. So here you see it, where in my top view, I have a cutting plane. Notice the cutting plane line goes completely through the object. My resulting view is shown here, where I am showing half the object in section. Okay. So again, full section. Comes all the way through the object. It's got both arrows on both ends, and it goes through. Now, when you're doing cutting plane lines, like in this instance, notice that it comes through here and we've got a conflict with center lines. Which line has precedence? Center lines or cutting plane lines? Cutting plane, all the way. Okay. You still do the center line, but what you'll do is you'll take the center line out that's on the horizontal method. Because you want these breaks, you know, this isn't a great job by the author. The breaks probably should sit right over here where they're nice and plain. And again, you know, just like with the center lines, when you create that as a phantom line, we did it yesterday as a P line, those breaks happen in a bad spot. Folks, you got to switch that back to continuous and make your own breaks. And do it with circles and trim it out so that we can see those breaks. You understand what I mean by that? Mm-hmm. Right. So in this case, I would make this a continuous line right here, and I'd make my own breaks right there. So this is it. Looking that way, there's a resulting view. Full section. Your most widely used one, by the way. Any questions on this one? Okay. All right, the next one, we're going to go to figure 1627. This is a half section. Now here the rules are going to start changing a little bit. With the full section, that was certainly orthographic projection, nothing really changes. The half section is used on circular items about a center. It has some rules that go with it. So here you see the cutting plane line in this top view. Now notice that we only have one arrow. So we're looking this way. The cutting plane line actually comes in through this object on this y-axis, hits the center point, and then goes to the left. This half of the object is drawn just like a full section, standard orthographic projection, where we come through, I'm in rock, I'm in air, I'm in rock, rock, air. And you see that down here. Here's where I'm in rock, air, to the center line. So we do that standard orthographic projection. Now the other half of the object, since it's symmetrical about a center, we don't show any hidden lines. All we show is the outline. We've already described the inside here. Now we need to describe the outside. That's what this side's for. So on the center line, we switch back to a normal projection, but we only do the outline. Okay? No hidden lines. Remember, the whole purpose of doing a section view is to get rid of those hidden lines. So let's not ruin the view by putting it in. Now, they still have this view. Okay, so they know there's a hole over here, even though we won't display it. They're seeing a good picture of the hole right here. So, cutting plane line, half section. Good on symmetrical objects about a center. Use section 1/2, just like a full section, you do an outline view on the other half. Any questions or thoughts? Cutting plane line only gets one arrow. Okay. That's the half section. The next one you've seen a little bit already. It's called the broken out section. And let's go to figure 1628. For some reason, this section is not utilized a whole lot in industry. But in my opinion, this is probably one of your better friends. It will do a lot of things for you if you pull this out and use it. Okay. In essence, on a broken out section, it's like we reach into an object and we just rip part of it off. That's what we do. There is no cutting plane with arrows on this. We use the short break line, and you see it right here. Remember, this is a very thick line, hand-drawn or made to appear as the material would normally break. Right? We're not given a view because we are then going to section right on this view. So as we look at this is standard orthographic projection through the whole object. We come up to our short break line, and now we are sectioning right through this area. Okay, there's nothing in that top view to tell you where it is. You have to do a little studying and look at the materials up there and say, oh, they're going through this hole and bringing it down that way. Okay. And so it's a really nice little section. It's much better than doing a full section, because like on this object, if we did a full section, we would never see these holes, right? Because we'd go right here. If we did a half section, we would come through here and here, we'd still never see those holes. Okay. So this is a case where a broken out section does a really nice job describing this little complex area right here. And in fact, I don't know if I wouldn't hesitate to do 2 of them on here. Maybe do another one right down in here to get this hole with object lines. You can do more than one if you want. You don't want to have every portion of it done in a broken out section. Don't get too carried away, but it's okay to do up to 2 or 3 if the object's big enough. So a broken out section. No cutting plane line in the adjacent view, you use the short break line. Then you section the area as if the front wasn't there. Broken out section. It's meant for little tiny areas that can't be explained in other methods. Any questions? Keep in mind, as we go through these, I'm just dealing with the figures. There's a lot of text that goes with all these, and I hope you back that up by reading that text that goes with that. Yes,
okay,
Lisa?
so would you still show all these views? I mean, would you still show that?
Well, this is just comparing and contrasting. I would show these 2.
So you wouldn't know that.
This is standard orthographic projection.
Okay.
So they're comparing and contrasting the 2 views. This is standard. This is with the broken out section. And you can kind of see the difference on what's going in here. That's a pretty tough read, especially with the runouts that occur. And I mean, we see those runouts right here.
Okay.
Okay. So we're not losing that information.
Okay.
But now we're seeing the set hole. Looks like some needle, almost looks like kind of a needle valve type of deal going on here, where something's plunging in and out maybe. Who knows what this part's really for, but. Okay. Same object, 2 different ways of displaying.
Gotcha.
Without a doubt, this is a little easier to read. Okay, any other questions?
Did they ever use these sections to eliminate an additional view, like in the multi-view?
Oh, yes. Mm-hmm. Yeah, they will eliminate other needs for views. You bet they will. The only other way to do that would be a removed, like a detail, which is one of our sections. But remember the removed convention, where we take objects out, we pull them out, blow them up to a larger scale. Okay? So this would remove the need for that on this object at least. Any other questions? Okay, okay, let's go to 1629. This is the revolved section. You want to use the revolved section when you have spokes, handles, arms, things like this that you cannot show in orthographic projection. This one might remind you a little bit of your high school biology lab. Remember when you would take an onion or something and you would slice it really, really thin and you'd put it on a slide and then look at it through a microscope? I think most of us did. I see Declan shaking his head, David. Yeah, we did that. I'll use the onion. Sometimes people do other things, but that you kind of think of that microscopic thin slice. Okay? That's what we're really kind of dealing with here. So in this one, we've got a big hub here and a hub here where I'm attaching the stuff. We'll never see this handle in orthographic projection because we have these 2 things in our way all the time, no matter how we look at it. And so what we're going to do is we're going to put our cutting plane line in just like on a full section. Okay? Now, it's gonna be slightly different because the cutting plane line goes here. Notice the arrows are looking this way. Normally, that would indicate that this view is going to be a section. It would have to rotate that way to get there. Now, this is my front view, this is my top. We don't have anything in the glass box out here, do we? The top's out there by itself. We don't have any rotations to the right. So what we end up doing is we're gonna take a thin slice right on that line. That's our little slide that we're gonna look through in the microscope. We're gonna rotate the thing down to here, and then we're gonna spin it 90 degrees, just the thin slice. Okay? So think of it this way. I'll come into the object, I'm gonna take that thin slice right here, I'm gonna take it to this location, and then rotate it 90 degrees so I can see it. That's what's going on. This is the shape of this arm.
Show how you got it.
What's that?
Can you show us how you got that shape?
Yeah, I took a thin slice, I
know,
rotated
where-
it there, and I rotated
How
it
you
like that.
projecting those lines, yeah, how you, I look at that and I don't get that in my head. So,
You would if you studied it for a minute. Now, how do I know this shape is here? I've got the part sitting in front of me, or I helped design it, or something of that nature.
Okay.
I mean, I didn't just get this view and come
that's what
up
I was
with
saying,
this.
I look at that, there's no way I'm gonna get that.
No, there's a whole design process that goes into all that too. But it's a way for us to display the shape of this arm. Now, we can put it just like this, right on the object. You can see how everything lines up. The preferred way is actually shown right underneath it. This is a little bit easier to read. Amy, we're in chapter 16 on page 778. This would be the preferred way to show it. It's going to require that you have enough room to do it, though. We would rather see break lines to give a little definition here. So, but we still need to have enough room. We're not impacting the projection on this hub and this hub. Nice little view. Common mistake you get with these is keep in mind that this is that short little section. I see this quite often, being as how I work with people that are learning the trade, and I'll see this bottom piece drawn like this. So it's lining up with that. It's not. Okay. Make sure you do it. You're doing it right on this center line. That's why it's square along that bottom, is because it's square up in the top view. Okay. So make sure you do the full-size replica of what that handle is here. This would work great on, I don't know, shovels, arms like this, flywheels, anything that has a structural component that's holding two items together. The revolved section is a really good section to pull out. Kind of good on this one? Take a thin slice, put it into the view, rotate it 90 degrees. All right, the next section came about because this one is hard to do on short, stubby objects. Okay. So we got the next one, which we call a removed section. This one kind of uses the removed convention that we had last chapter, chapter 10. And you can kind of see how it works. Here's kind of the same object, but here, the distance in between here, our structural component is much smaller. Same cutting plane line that we did have. Now, we've got one extra thing. Since we don't have enough room to display the section here, you can see how crowded it is, we're going to pull it off the object. Now, the second we're going to take this section and create another view out of it, we need to identify it. Therefore, they've interjected the letters A. On sections, we generally use letters. Okay, so A, B, C, D, E, F, so on. Do not use the letters I and O. Okay, we do not use those because they can be confused with numbers, right? Kind of like hotels don't put a 13th floor on. They skip that. We do the same thing. Just when you get to I, skip it. When you get to 0, skip it. Will you do enough sections to get through the whole alphabet? Yeah, some things. You'll go through the alphabet 2 or 3 times. We'll have section AA, AAA. Then we're doing a lot of sections, but yes, we do what we need to do to display the object. So once they do that, it's not here, they're going to pull it off, make sure it has a title underneath it so that somebody can find it. Remember when I talked the other day about a bug that also references a different page? This one should be on the same page because it goes with the object. Should be on the same page. You want to be a little bit careful, and one thing I don't like about this example, we do not want people to confuse that with a right view in this setup. So I would get it off further. Don't let them make that connection with the glass box here, because they're not. They need to make the connection with the cutting plane line, not the glass box.
Does it have to be lined up?
No, it does
Okay.
not.
It must be just adjacent.
No, I would take it and stick it in the bottom corner, the top right, or somewhere off here where it's not confused with this thing being turned. They've got the AA, they've got the cutting plane line, they can find it, they can then make that connection. But we want to make sure it's not in that rotation sequence that we use. So the removed section. Use this one when the revolved creates a confusing view like this one. Again, meant for structural items. A really good example of, in fact, probably the one that is probably the most useful of a revolved or a removed section is this one right here down below it.
A rod?
Okay, here we have lots of room, but they elected not to use the revolved here, here, and here because it would be too busy. They did a remove, and what they're basically showing is the change in shape of this top channel. At this point, it's a fairly small little V cut. By you get to here, it's starting to widen out a little bit. That's where the machinist is going to get his information, is at this point, he's going to straight line, he or she is going to straight line in between those 2 points. And then they come to here, and it's widened out even more, and they straight line in between C and B to get that handle built to the right shape and description. So a real good use of what a removed section is meant for, right here.
I wish they used objects like that more often because I recognize it.
Yeah.
It's a lot easier.
Yeah, I mean,
You can see the point.
yeah, and Andy, you're kind of talking like you've been out in the industry, you've seen these prints, you kind of seen that this stuff's not used a whole lot. It should be used, but at the same time, based on somebody's training, how much time it takes, because time is money. Sometimes they skip shortcuts, which I wish they wouldn't, but it's like any job. People at sometimes do that. We won't. Okay, we'll take that time to do it, because we know we're gonna make that money up in the end, right? Take it out here, and you'll save it a lot down the road. Hopefully your employer gives you the time to do that. There is one more example here, and I just want to point this one out on figure 1632. What's this one? Still a removed section.
Make it bigger.
Okay, but now they have technically also brought in the removed convention. Okay. So here, they're using a different cutting plane line, right? Now we've got the circular shape because we're not really cutting the object and doing a rotation on it. We're just taking that shape, we're going to bring it out, but we are going to section it. And that's really technically the same thing as the other one, but here we are not rotating the object at 90 degrees, that little biology slice that you would put on a slide. Okay, that's the removed section. This one is probably your most widely used one, this one right here, other than the full section. Like, we use this a lot. Pretty powerful little descriptive device. All right, the next one, offset section. This is figure 1634. Now this one's a little bit different. It's got its roots tied into a full section, but we do some different things with it. Let's first look at the cutting plane line. Here's the cutting plane line right here. We still have our arrow showing line of sight. So it's in the top view here with our cutting plane. We're looking this way. We're throwing this part away. But what we do at the offset section, as opposed to the full section, is when critical parts don't fall on the same line. We bend the cutting plane line to pass through these critical areas. The bend is always 90 degrees. Always. Okay, we do not bend it at an angle. I wouldn't come in here and say, well, I'm going to take this and go from there to there. No, we always do a 90-degree bend on our cutting plane line. Now, the reason for that is we don't want any foreshortened surfaces. So as we look at this section, so I take it, I cut through this hole, that's going to describe those two. Then I'm going to bend to get on the center of this hole, I'm going to go through it, it's going to describe that. Then I'm going to bend and go through this slot and describe that. Now, when I project this, I project true size from here to here, and that gives me this portion of the drawing. Then I move and project from here to here, that gives me that portion of the drawing. And I only project what's on that line. Then I move to the next one, which is from here to here. Well, I didn't draw it real straight, it goes through the end. That is all that's projected is along that line. You do not project these edges right here because they're imaginary, right? The cutting plane line's imaginary. Those bends are imaginary. Don't project the lines where the cutting plane bends here, like they show right here, because you're creating a false surface. So we do not project that bend. Should look just like this guy in the middle. So the offset section. Use it when the full section doesn't work because your objects are not on the same horizontal or vertical axis, because we can bend this line. This one, by the way, is one of the most useful ones in architecture. Okay, this is a great one for architecture because we bend through all different types of roofs. We might go through a hip roof, a gable roof, we might go through vaulted ceilings. We can describe much of this in one section, whereas opposed to before, we had drawn sections at every location. Okay. Real powerful little section. Any questions on this one?
You said that the cutting lines are sometimes omitted, but in this one, you would never omit it.
No, I would never omit this one. Yeah, because the location of the cut wouldn't be obvious, especially where we're going to move it through the length where we're taking that cut.
Okay, I'm back to my same question though. You're given this one because if you're just given the top, you're not gonna know. So you have this one to look at to do your cut. I mean, how else are you going to know that from the top? Only from the top, you're not gonna know the dimensions. You're not gonna know how that looks. So you're given this.
Yeah, you're given this
Given that,
information.
okay. So then you can make your cutting.
Or you have the
Okay.
object in your
Yeah, I guess
hand.
that was my question. It's like, how the heck did you know what that looked like? You didn't have this.
Well, we would have the device, or we would have other drawings, or we would be in the development process of these drawings. And so, yeah, we're
If
making
you
them
have
up.
that, then you'd give them this, so they wouldn't need that.
Yeah.
Okay.
Yeah, this would be the preferred way to show this, as opposed to orthographic projection like this.
Why doesn't the view show the line as it goes? Why is it,
Okay, like this line here,
no, like the bottom of it? Why is, like you have that little part up there and then it goes down and then you have the middle and then it goes down and then you have that left side? Why doesn't it follow that?
oh, it does. This piece right here is this outside circle. Okay, so right here is coming across this flat till it hits here, and then there's a cylinder on top of that. Can you see that right here? That's what you're seeing. And then it's got 3 circles here because it's got a counterbore in the middle of it. But the outside circle is this positive cylinder, which you see right here. Is that what you're talking about, Missy? Yeah, that's the bump up. You're seeing the limiting element right here and right here of this cylinder. Are you good with that? Any other questions? Okay, that's the offset section. That's number 6. By the way, there's a couple more examples of these. Let's just go to the next page before we leave this. Okay, so here's one where they've done two. We're going to come back to this one tomorrow because it's kind of an important rule. Draw every section as if there's no other section being taken. Okay, and this is a good example of it where they're doing an offset section. They're catching these three holes as they come through here. Then there's these two areas, right, 3 areas here that were also, they did 2 of them. So in essence, they're rotating for 2 front views, taken at different locations. But you draw both of these as if the other one didn't occur. You just take them case by case situation. Don't let your other views influence what's going on. So this one's right along that line. So from there to there is shown from here to here. From there to there is shown right there. There to there is shown from here over.
And you're talking about just the way they're projected, not the way you determine what to cut.
That is correct, the way they're projected. You project every view as if it's a standalone view. Any other questions on this one? Okay. Let's go to figure 1646. Now, we use the remove convention to do a removed section. We're going to use the revolved convention to do what we call an aligned section. So I got different names here, so you got to keep this straight. Remember, the revolved convention we talked about in chapter 10 was taking items about a center, revolving them to the quadrant point, and then projecting them to remove this foreshortened appearance. Okay? We're going to do the same thing now, but now we're going to do it in section. Now, when we do it in section, our cutting plane line shows them where we're going to revolve at. So again, your cutting plane line has 2 arrows.